Hi, this is Jim Zuber with Quality Logic. I'd like to share with you an abridged snippet from our OpenADR 2.0 workshop. This session covers OpenADR from a big picture perspective. There are two actors in OpenADR communication exchanges. The first actor is a virtual top node, referred to as a VTN. The VTN's role is to transmit demand response events to other nodes. The second actor is a virtual end node referred to as a VEN or VEN. The VEN's role is to receive demand response events and to respond to them, as well as to control demand-side resources. All communication is between pairs of VTNs and VENs. Interactions between VTNs and VENs is a one-to-many relationship. As the diagram illustrates, a VTN may communicate with one or more parties playing the role of VENs, who in turn take on the role of the VTN to communicate with additional downstream resources playing the role of VENs. A typical interaction pattern would have the utility playing the role of VTN communicating with a residence or small business playing the role of VENs. Or perhaps the utility playing the role of the VTN would first communicate with an aggregator playing the role of a VEN, who would switch hats, becoming a VTN, in order to propagate events downstream to other commercial or residential resources playing the role of VENs. Let's drill into this a bit more from a residential perspective. One scenario would have the utility playing the role of a VTN, sending OpenADR events direct to a programmable thermostat that has an embedded VEN. Or, more likely, the utility playing the role of the VTN would send the events to a gateway device via OpenADR 2.0, with the gateway using other protocols such as SEP2 to actually communicate with the thermostat itself. From a commercial perspective, the events from the VTN would most likely be directed at a facility energy management system, which would then use BACnet, OpenADR, or other protocols to propagate the event to more granular resources within the facility. Think of a VEN as a logical interface behind which are the load-shedding resources. OpenADR provides for demand response message exchange and not demand response application logic. There are no constraints on how messages arriving at one node are translated into subsequent messages. For instance, an operator at the console of a demand response management system at the utility may initiate an event. What happens is that the details of the event get packaged into an XML payload and shipped via OpenADR messages from the utility to the aggregator in this example. At the aggregator, the message is unpacked and the details of the demand response event are pushed up into the aggregator's application, which will decide how to propagate the information downstream. The process repeats itself as the message is sent from the aggregator to the facility. The job of OpenADR is to deliver the message, not to decide what to do with it. I hope you enjoyed this brief snapshot of our OpenADR training class and that you can join us at a future training session.